uh, actually get some plotting done. So let me share my screen. Uh, yeah, okay. Everyone can see this, or I think so. I think people can see. Great. Yeah, so we're going to talk about doing data visualization with Tilia, and that's what we'll spend the majority of our time on. But before we do that, I did just want to give some brief context about where Tilia comes from, which depends on sort of this history of computer drawn pollen diagrams, starting in the 70s at places like the University of Cambridge and University of Minnesota on these big mainframes where you put your punch cards into it. But at that point, the pollen diagrams that they were generating, like this one, were, not publication ready in the words of the paleoecologist John Burks. I think they look pretty okay, but yeah, I guess they don't compare to that the hand-drawn pollen tradition at that moment. And also just because you'd have to go to this mainframe, you didn't have a personal computer, they're pretty inconvenient to use. Yeah, this is like Margaret Davis's 1958 hand-drawn pollen diagram, which, you can see it's a lot prettier. But starting in the mid 80s, there was this microcomputer revolution, right? Everyone got their personal computers, and in that moment, a lot of new pollen plotting programs were being developed by professors at universities. This is just a subset of them. There are a lot more than these, and yeah, they all look a lot better than that Pol Data one from John Burks, and they're easier to use because they're on your personal computer. That said, still like relatively difficult or like not as easy as they are to use today. Like Tilia, Tilia was one of these, but it was an MS-DOS program, right? Based a command line interface. It didn't have a graphical user interface. Um, yeah, Tilia did come around in this moment. I guess to me, the question is like, why do we still have Tilia? Given that, or why did, I mean, some of these still exist, like P simple. I think people still use that. But right, the question, why do we still have Tilia? Why is this the one that we return to? Is really the fact that it was connected from the beginning to some databasing efforts like the North American Pollen Database and the European Pollen Database. It was the medium through which people uploaded their pollen or other stratigraphic data to those early databases, which later became which were later integrated into the Neotoma Paleoecology Database. So that's sort of a brief history. Oh, and this is sort of interesting too, just that there is a record of IT support for Tilia from as early as 1991. Dr. Triage would answer people's questions in this newsletter. So I just think that's a sort of cool archive that we have access to, how people, the kinds of friction that have been generated from people, you know, trying to use Tilia over the past, gosh, 30 years. That's enough history, though. Let's get into the main thing, which is how do we actually use Tilia to plot some pollen? I'm going to focus on pollen, but again, you can use any sort of stratigraphic proxy you want. You can also, I suppose, you could use surface samples, but I mean, mainly makes sense for stratigraphic stuff. Oh yeah, but before we do that, just to motivate why Tilia rather than, our library, there are maybe a few different kinds of reasons, but to me, the main thing is that Tilia has a graphical user interface, so you don't really need to know any coding to get some pretty nice pollen diagrams. So yeah, I think that Tilia is still a useful tool, and you know, it's worth it to learn a little bit how to use it, and it's not too difficult. So with that, hopefully, people have already downloaded Tilia onto their computers. But if you haven't, this would be a good opportunity to do so. If you go to this website, there will be a link there that links to a Google form. If you fill out that Google form, you should get an automatic email from Jessica Blois that will uh, show you how to install Tilia, and it gives you the user and license information to use it. It does require Windows or Windows emulator like Parallels, so that's the downside. But I guess I'll give you all a few seconds to start working on that download process if you haven't done it already. And if you have any issues with it, you can put those in the chat and we can try to address them. Yeah. And throughout this, feel free to interrupt with any questions that you have, or if you're experiencing any issues. Tilia can be a little bit buggy, um, so yeah, issues may arise. Well, okay, why don't we keep going on the assumption that let's see. Haley asks, if I downloaded for training at Cost Paleo Open Meeting in France in January, then should it still be good to go? I think so. I think you should. Yeah, I think that should work for you. But let me know if you have any issues. Um, so before we start working on the pollen plotting, we need to actually get some data. Maybe you already have some data on hand that you can use. If so, that's great. I'm going to show you how to download some data from Neotoma and then massage it a little and then basically paste it back into a new Tilia window, and we can use that to do our plotting. But oh, how do I? Oh, yeah, let me actually navigate to Tilia. Here it is. If you open Tilia, hopefully it looks a little bit like this for y'all. I'm on a Mac, so this is like embedded in a Windows emulator for me. Um, but to actually get that data, first I'm gonna click on File, press the button Neotoma, which will take me to an interface that actually allows me to grab data from the website, or sorry, from the database. And so I'm going to search in the site name for chochos because I want to grab this site called Laguna de Chochos. And I'll search for it. Again, you can look for whatever data you want. There could potentially be issues with it. For instance, when you're plotting, Tilia doesn't like it if your sample depths or ages are not in ascending order. So that's one thing to work out for, and you could get other issues potentially. So you might want to go with this one just to do it with me, but yeah, could be cool to try your own and see what happens. So yes, I'm going to download the pollen and the geochronological data set associated with Laguna de Chochos. It takes a second to actually uh, download. You can see in the left-hand corner the various APIs that are operating. Okay, some geochronology analysis units are not in the spreadsheet. I always say yes to this. To be honest, I'm not exactly sure what analysis units they're talking about, or maybe those are the ones at the end. Anyway, um, so I actually want to grab all of this data, but uh, then I want to copy and paste it, and it can be a little finicky to grab a bunch of cells. But it should look like this as you're grabbing. Go all the way to the left or right. Go all the way down. It should be about 150 rows. Um, oop, okay, copy paste or copy, and then I'm actually going to go to a Google Sheet, one that I already have up here, and so I basically going to paste them in like this. You can do it on your own uh, spreadsheet. I'm seeing some questions. Uh, okay. I'm getting a lot of load error, or a load of errors, so I guess better just watching it. Um, Yeah, I guess if you're getting some errors, that could be a good idea. If they are like the like reparsing DOM error, that's like just the general or like build tree, reparse DOM build tree. That's the general error. Doesn't It's not too informative, but sometimes if you just click past it, things will end up being okay. And if it's a more specific error, feel free to, oh, that, yeah, maybe we should talk after this, or maybe someone will be able to help you with that. Yeah, we're gonna figure it out. But yeah, just to keep going for the sake of time on this part, um, I'm just gonna reformat this a little bit. You can take out the chronologies if you want and just use depths, or actually, I guess I didn't grab the depths. So let's use one of these chronologies. Let's just use the first one, Bush et al., 2005. I'll delete these columns, or sorry, rows. Um, and let's see, these, I think these are the columns for taphonomy and context, which are almost always empty. So I'm just gonna delete these, for the sake of compactness. Also delete, you don't need to delete this stuff. Just think it makes it look a little clearer, the sample analyst. Um, so the first thing that we want to do, basically what we want to do is convert these counts into percentages. So in order to do that, we need to calculate pollen sums by depth first. So I'm actually going to, I did paste this stuff in a little bit earlier, and I'm going to use this version of the spreadsheet just because I have some formulas embedded in here already. The important one for this is to, yeah, calculate this statement, sum ifs, and I'm actually going to paste this into the chat for other people to use uh, in case that's helpful. Also, you know what I can also do is actually like share a copy of this data set. Maybe that'll be easier just 'cause I'm seeing that some people are having some errors trying to get the data. So what if I paste a link to this?
Nick, just one thing. It might be because there's so many people trying to access the database at once. So
Um,
I would just suggest if you're having this error right now at the beginning step, since Nick is proceeding, maybe just follow along with him right now, and then we can swing back at the end and try to re-download the data for you so that then you can follow along with the recording afterwards. Does that sound like a good plan?
That makes sense to me. I think what I will also do is just share this as like with people to have viewer status, and that way you can copy paste into your own. And I well, so then I guess it raises the question: is people or will people just opening up their own Tilia files, will that also slow things down?
Nope, it's
Um,
on their local computer. It should be okay. It's accessing the database remotely that will cause that. So yeah.
yeah, okay, that makes sense. Cool. That sounds good to me. And apologies everyone about the Tilia capacity issue. I think you're probably right, Sarah, about that being the issue. Um, Okay, but yeah, as I was saying, in order to convert to percentages, first we want to calculate the pollen sums by sample depth or age in this case. And we can use this formula, which I've pasted into the chat in order to do that. It's a conditional sum. Basically, it goes through columns B2 through B138, where I've put these ecological groups, which correspond to ecological categories like upland herbs, vascular cryptogams, trees and shrubs. Let's see if we laboratory, those are like microsphere suspensions. Um, and okay, yeah, it goes through those groups, and then it will just sum um columns. It will just sum in column F where the corresponding group is not equal to laboratory and does not have the word aqueous in it. So we're excluding laboratory because those microsphere suspensions are like in the thousands, and so it'll just make our percentages look really small if we include these microspheres in the pollen sum. And we're excluding anything that is aqueous in it because, we're presumably more interested in what's happening outside of our pond than the like endogenous dynamics. So yeah, so we're gonna ignore the aqueous. And I put these dollar signs in front of the B's so that when we auto-populate the rest of these sample depths, that it doesn't change what column it's looking at. The group, ecological group stays the same. But there are no dollar signs in front of the F because we do want the sum to be different for each of these sample depth columns. So that's a little bit involved. So let me know if there are any questions about that. And I'll start to move this to move this to the side. It'll take a second. Okay, great. We have these pollen sums, and the next thing to do is to make some pollen percentages. What you want to do is make a new sheet. I already made one where you just copy and paste over your metadata from the first sheet, which are your basically your taxa names and the ecological groups associated with them. Oh, Alejandra.
Yeah, I just have a question. So, in Tilia, you also have the option to do this kind of like basic calculations, like calculate percentages and sums. Do you rather do it in an Excel or do it in Tilia?
I guess what makes Excel a little bit, I mean, it's a good question. Yeah, you probably could do it in Tilia, and you could probably exclude I guess yeah, I guess you could probably also exclude the ecological groups in Tilia that you don't care about. I just feel a little bit more comfortable with Google Sheets personally, and I get nervous about Tilia crashing, so that's why I use Google Sheets. But you're right, you might be able to do all of this in Tilia itself. Um, yeah. So just to keep going, once you've pasted in all this metadata, you want a new formula, which I can put in the chat too. This will be the formula for actually calculating our percentages. You go, yeah, equals, and then go to the first page, the count here in for Acana type at age 136 divided by the pollen sum we calculated earlier. Notice we put a dollar sign here so that when we move this down, the pollen sum value doesn't go down, multiplied by 100. And then we just sort of auto-populate that. Okay, and grab this and move to the side. And this should get us our percentages. And once we do that, we're going to go back to Tilia. Yeah, there we are. We'll go back to Tilia. And oh yeah, we so this was the data I downloaded earlier, but we're going to make a new file now. Take a second. And we're going to copy and paste our metadata back in. So we'll grab the names from here, paste them in. I'll grab the element and ecological group too. Maybe that's all I'm going to care about for now. Okay, ecological group. We'll put that in group. And the element, we'll put an element, just whether it's pollen or spore, stomate. What am I looking for? Oh yeah, here it is. We'll put in our ages up at this line, or you could put depths there too, whatever you prefer. Oop. And then we'll just actually put in all those percentages we just calculated, making sure things are lined up correctly. So that's pretty good. Next thing we want to do is save. So I'll save this as example, and then TLX is the Tilia XML file. Um, and once we're at this step, Uh, we to start make our first basic plot, we just click on this diagram button and let's hope this works. Oh, sample numbers in column BT. Let's see, where's BT? Okay. Oh, yeah, I'm not sure how these got in. It's there. Okay, let's save again and paste. Okay, this looks our print diagram. This looks good. It's just asking us which elements we want to include. Why don't we include everything except for this unidentified? Oh, and also volume and quantity added. Those are, and actually concentration too. That stuff's probably not what we want, but let's include the other stuff. And here's our pollen diagram. It doesn't necessarily look great yet, but this is where this is a great start, I think. And we can zoom in by clicking fit to height. So yeah, that's the basics for making a diagram in Tilia. Let's see, what's the next thing that we want to work on? Uh, Next thing we'll do is just about moving columns around in Tilia, doing a little bit of styling modification. And this is actually pretty important, looking at how we can exaggerate the scale of an important taxon with low visibility. Okay, so to start with, removing or rearranging columns. One thing you can try to do is just click on the column you care about. It can be a little difficult though, because like now you can see I actually have the Doni pollen clicked, but I was trying to click on Dryopteris. Okay, there I have Dryopteris. I actually don't want to get rid of it, but we can move it around. So I'm bringing it to the beginning. This can be useful if like you want to put, say, all your herbs together or all your woody plants together and they're not already together in your spreadsheet order. Moving it around can be helpful like that. Let's say you wanted to get rid of something that seems to like almost always be zero, like this. I'm not sure what I have. I guess I have the Atrium tribe at this. Oh wait, what is selected? Um, don't love how this how that rectangle is staying there. So actually, if you're like not sure what you're selecting, one thing you can do is click on graph style, and then you can really be explicit about what you're trying to select here. So let's say we want to delete the Ethereum type spore. I mean, that's a way to select it. Actually, to delete it, one thing you can do is go to variables, and then for well, where did it go? Uh, let's say for alternanthera type pollen, if we wanted to delete that, we can just click on this button, skip, press OK. That'll get rid of it in our actual pollen diagram. Or you can just like click this X to get rid of something. Uh, yeah, so that's moving stuff around, deleting things. And lastly, or to modify style. So let's say we do want to modify the style of Dryopteris type spore. We can go to graph style. We can change the color of the main curve to say aqua. Let's solid fill. Apply that. There you go. You can see. So, and you can, you can select multiple variables, like select all to do that if you wanted to, and apply um, solid aqua. Well, wait, is that? Well, that's supposed to work. I'm not going to worry about it for now. But yeah, one other important thing that I wanted to show you at this point is how to exaggerate the silhouette of a taxon that might not show up a lot, but maybe when it does show up, it's important. So for instance, let's say you have a taxon that is not wind pollinated, maybe it's insect pollinated, but it shows up still a little bit, and it has really important, you know, consequences for the state of your ecosystem in the past. One way to get to that, let's see, Cecropia type pollen. Is that what I want to have? Yeah, I think that'll do. Um, so what you want to do is put in an exaggeration factor, let's say 5. and then put in an exaggeration color, medium orchid, and maybe a main curve color, gold. And when we apply that, you can see the actual curve there in gold and then exaggerated in purple. So that can be a way to visually emphasize the importance of the taxon that doesn't show up too much. Of course, when you do this, you want to be really explicit in your figure caption or somewhere about what that means, right? You don't want people to actually think that this purple is the actual incident. It's just an exaggeration of dynamics that might be harder to see otherwise. Um, yeah, so that's pollen diagram modification. Let's see. So, okay, summary dynamics. This is something important that you can do. You can basically, if you want to have a column at the end, say, where you show the dynamics of upland herbs versus trees and shrubs generally, there's a way to get that done in Tilia. It does require going back to here. So I'm actually going to, oh wait, let me get rid of that. Um, I'm going to X out of this for now, just so that we don't have problems later. So so yeah, so you do want to do this kind of at the beginning. I just didn't want to show you because I wanted to write them because I wanted to show how to make the pollen sum or how to make the pollen graph more generally. But to get a summary diagram, first you want to make pollen sums by group type, which you can do where the sigma is. Can type in some names for each group: upland herbs, vascular cryptogams, trees and shrubs, aquatic vascular plants, unidentified laboratory plant, aquatic bryophyte, vascular, whom I think this was like a printing error to say ignore, and seed plants. Okay, great. And let's see, I think we just need to click OK, and that should give us some oh, too far. Yeah, here are sums at the bottom of this diagram. Uh um yeah, so that's the important thing. Then we actually first let's save where we're at. Then we'll go back into the diagram. Let's see. Don't want unidentified, don't want volume. Or pollen. Okay. Fit to height. And we should see at the end of here all of those groups we do: upland herbs, vascular cryptograms, trees, shrubs, aquatic vascular plants. Okay, but to actually combine them, what we need to do is go into variables, navigate down here where these sums are, and let's see, we're basically going to stack trees and shrubs. So we want trees and shrubs to be at the top of this list of sums. So that will be our base. And we're going to stack on top of it. Okay, we want upland herbs to be at the bottom of the things we're going to stack. Let's remove ignore out of this. Not that it matters that much. But then we are just going to stack, right? Stack vascular cryptogams, aquatic vascular plants, unidentified. Actually, let's get laboratory out of here too. Plant, aquatic bryophyte, vascular seed plants, upland herbs. Okay. Click OK. And you can see them here. Uh, but I mean, what does it actually mean? In order to see what's happening with the shrubs versus the uh, upland herbs, you have to go back into graph style. Um, go to trees and shrubs, which is okay, already selected. Change its color to be, say, teal. Apply that. Okay. So that's telling you something. This is what trees and shrubs are doing. And then let's also select um, upland herbs. Um, Select that. Okay. And let's change its color to midnight blue, say. Apply that. And well, it's sort of hard to see. Let me make it a different cornflower blue. Okay. And okay, you can see that. So this is one way to do summary dynamics with trees and shrubs versus herbs, and the other stuff's in the middle. You know, doesn't necessarily look that great, I think, because we're missing this laboratory stuff, actually. Maybe we should have put that in there. I mean, really, we just want to exclude the laboratory sum in general because we don't care about the microsphere stuff. But the problem is that it's like now it's affecting our pollen percentages, so it's not looking like the nice rectangle we would have wished for. But that's how you do that in theory. I think if you play with it a little, you can figure out how to make it look a bit nicer. Another thing just to point out is that all of the names are on top of each other. This is something you can fix when you export your image to a image processor like Adobe Illustrator, or I like to use Inkscape. So that's something you can fix. But yeah, that's how to do summary dynamics in general. Let me see, is there any question? Oh, I'm seeing a question about whether the Tilia will be, or whether the video will be emailed out. Yes, it is going to be emailed out uh, to people, so you will be able to review this more slowly. I apologize if this is going too fast, and I do like, yeah, again, if at any point you want me to slow down for a second or you need me to go over something again, I would be really happy to do that. So just keep that in mind. That's how you do summary dynamics. Okay. The next thing, and one of the last things that I want to talk about, are making a cluster analysis. So to do that, this is again something you'd want to do a little bit before making your graph. So I'm going to X out of that. And what I'm going to go do is go to insert a worksheet, insert a CONUS worksheet. And let's see, what groups do we want to include in our CONUS analysis? So, and let me also say, what is CONUS? CONUS is constrained stratigraphic clustering, basically. So, uh, looking at where the major divisions between categories of plants are, or categories of which sample depths are the most similar, most different from each other. Um, a visualization of that. Let's include these. Okay. So you'll see that that actually makes this CONUS worksheet down here. So we go back to actually visualize the CONUS. Oh, we want to save this CONUS diagram. File save as. Hmm. Shoot, we should be able to save it as a DGX file. Now I'm not seeing that. Makes me a little nervous. Oh wait, no, cancel. Uh, File save. Okay, well, I might be forgetting how to do this a little, but let's see what happens when we try to make our diagram again and try to add in a CONUS. Okay, fit to height just to make it look better, and then here's the where we can add in our CONUS. Right, we're supposed to open a DGX file. Well, I think this is an earlier DGX file I made, not the current one. So I am going to have to get back to you all on how to actually save your CONUS worksheet as a DGX file. I apologize. That's something I should have remembered how to do. Um, yeah, thanks, Caleb. Yeah, the kind of stuff can be tricky. But anyway, let's just open this one since we have it, and in our follow-up email, I'll make sure to describe how to actually make your DGX file. There are various things here that you can play around with, whether you're doing a total sum of squares, increase sum of squares, etc., what color you're going to make it with. But let's just leave it as it is for now. Click OK, and then here you've got a conus at the end. So that's great. I mean, the issue is this is some conus file from a different pollen diagram. But if it were our actual conus worksheet, then it would be great. Um, yeah, that's conus. And the last thing is just how to save your image as an EMF, which you can go do by going to File, Export to an EMF file, example file, and save it. And then you can convert your EMF file to an SVG, which is better for a lot of image manipulation softwares like Adobe Illustrator, and you can do that conversion through a website like this one. If you want to, just Google EMF to SVG, then load it up into something like Inkscape, which I have here. And I don't use Inkscape that much. It can be a little finicky, or but whatever your preferred image manipulation software is. Uh, and then, it just allows for more manipulation of the diagram you have. You can add in text too um with the proper tool. Um yeah, so I don't want to get too much into this, or because I don't know if you're going to be using Inkscape or what your particular Illustrator software would be. So I might just want to leave it at that. Uh and we're pretty early, still have like you know a lot of time. If there are any questions about using the software or any issues, thanks, Alejandra. Right, you can download Inkscape there. And like I said, I will get back to y'all about the DGX issue, or maybe we can just do a little bit of trying to play around with that right now. Gosh. Well, I don't know. Uh, yeah, the DGX thing, that's gonna bug me, but I will get back to y'all about that. Yeah, so I don't know. Maybe we should leave it there. Are there any questions people have? Yeah, well, if not, I'm grateful to y'all for coming to learn about the use of Tilia. It is sort of a funny software. It has its quirks. But I think there really is a lot to be said in its favor, and I think it's sort of like beautiful in that it is sort of the cathexis of like all this ecological data software energy over the past, 40 years or so. So I think it's a really interesting object.
Thanks, Nick.
Absolutely.
Well, thank you, everyone. Thank you very much, Nick. So just to double check, so we will send out an email with the YouTube recording, and also we have all the previous workshops in the YouTube channel, like of Neotoma, so I will also send that information. And yeah, so we will have another workshop next on March, so please stay tuned just in case. Like we're gonna do, actually, Nick is gonna do another one using Rioja, which is an R package to also make um pollen diagrams in R. So if you have suggestions, please email us. We're always looking for people interested in doing this kind of event, workshops. Yeah, I think that was about it. Thank you very much, everyone.
Yeah, and I see a question from Carolina about the difference between overlay and stack in that variable sum. And just to say that what I believe the difference is that when you overlay multiple variables, they're literally on top of each other. Whereas when you stack them, you you get them stacked. I mean, am I really explaining or am I just repeating the language? I'm not sure when you would want to use overlay. I usually just stack.
Yeah, because I think it's the difference of like whether you want them to be like additively lined up next to one another or if they're just lined up next to one another. So I think if one taxon is significantly higher than another one and you want them plotted on the same axis to save space, you might overlay. But if you want them added together, but their distinct curves show, then you would want to stack them. So it's just, play around with it and see what works best. But one other question, Nick, did you send out your tutorial, the written down, like our markdown tutorial?
No, you're right. That would be helpful to people too. Yeah. I'll make sure to send that out with Alejandra's email.
Cool. Yeah, maybe send it with the recording because sometimes it's like helpful to have the text there along with the recording.
Totally.
Oh, okay. Thank you very much, everyone. Thank you, Nick, again. And I hope you have a really good rest of your day.
Yeah, thanks, Nick. Thanks, everybody.
Bye.
Yeah.
Take care.
And see y'all.